Right, so chapter 3 starts with a lot of stuff about the string class, and I think the first thing it makes the point is that string class, I sort of said it here in the notes, that it's really one of the most fundamental classes in Java language because we use it all the time. You know, it's sort of almost every class will have some sort of usage of string, and of course when you write a main method like there's one here, the first thing we come across, you're passing in an array of strings in there in case you want to, you know, like we've done in chapter 1, in case you want to pass in command line arguments. So strings are really fundamental class. It's obviously, a string is just a representation of a series of characters, a word, sentence, etc. And very obviously commonly used class there. And the first thing to show is that if I try and create a new class, now say if I was very narcissistic and I wanted to create my own version of this class called John string, and it behaved exactly like a string, but I just appended the word John to everything. I tried to do that by doing this. We do inheritance and extension later on, but I'm sure you already know the concept of it. I try to extend the string class. It does everything that string class does, but I just add the string John to it or something like that. But you can see we've got this red non-compilation message here. You see we can't inherit from java.lang.String. So what does that mean exactly? Well, you can open the string class and have a look at it. Here it is. This is the string class here, and you can see it's the 3,000 plus line class with lots of comments and things in it. Very mature class. And if I just go back to that bit again at the start, that's why we can't inherit from it. It's a final class. So what that means is that the Java people, Java developers, have decided, well, no, this is one of our fundamental classes. We don't want anyone else messing around with it, inheriting it, doing their own thing with it. This is the definitive string class, and no one else can extend it and do other things with it. Of course, there's nothing stopping me just creating my own class and doing those silly things. That compiles fine now, and I can have my own methods in it, but it's in no way connected to the actual string class. Come to that, I could even create my own class called string, and it's probably, yes, okay. I'd have to change that here, rename for it to actually compile, because if you remember, public classes have to be defined in a file of the same name. So that actually compiles, and I could write all my methods and do everything the string class does, but appends the word John to it if I wanted to. But it's, as I say, I can't do it by extending the string class. And of course, if I did that, it'd be a very mean thing to do. It'd be a very confusing thing to anyone who came to use my code, because they'd be thinking, oh, this string class is behaving strangely. But just to point out, the string is a final class. It's a final class, and so you can't extend from it. So going back to the demo, there's all sorts of different methods and things on this class that we can use, and I think because I've created that, this is now compiling. This is now not compiling because I've given it some ambiguity here, because I've now created my own string, and yet there is that java.lang.String. So I'm going to just delete that, so it doesn't cause that confusion. Anyway. There we go. Now this now is pointing to the proper string now. There's no ambiguity there. So one thing to mention is that string's kind of quite a special class, because it is an object, not a primitive. So if you remember back, primitives are primitive data types like integers, you know, chars, floats, whatever. All those primitive types that you can just do something like this with. You can say int I equals 1. You can. It's not an object. It's a primitive. You can just declare it and initialize it straight away on the same line. Objects, you can't do that. Objects are something that you have to use the new keyword, which then creates an object on the heap of that class, and that's what string is. And we know another way you can know that something is an object is because it does have its own .java file. It's a class, public class string. It's a class, and the classes are the abstraction of an object. So you do a new string and it creates an object. So just reiterating that string is an object. It's not a primitive, but it's strange because it can kind of behave a bit like a primitive. It's almost like Java's equivalent of a quantum particle. You know, like quantum particles, they can behave like particles or waves. They're a bit strange. Well, string is kind of like Java's equivalent. It can behave like an object or a primitive. And you can see it here. So here it is behaving like a traditional Java object. So string my name equals new string John. So that's just as any other object, like how we would instantiate an animal or object or anything, any standard Java object. We use that new thing, and as soon as you call that new thing, it reserves memory space for it and creates the object on the heap. But here, so this is where it differs. This is the same thing. We've got a string with the value John there and there, but here it's almost behaving like a primitive. We're not using the new keyword. So any other class, like if we were to do animal, if we were to do this, that doesn't work. That's not going to work like that because we're sort of treating it like a primitive, the animal, but we can't do it for almost all other Java objects. But string is a special case. It allows us to do this. And the reason it allows us to do this is because strings are so common. You get them created so much in programs. And for example, you might want to you get a name, a name read in from a file, compare it to a name from another source, check that they're equal, or append something to it, find a character here, split it into substrings, etc. So you're constantly manipulating strings. If that was creating new objects all the time like this, every time you wanted to manipulate a string, you'd soon have thousands of them on the heap. So it's created that Java's created this sort of strategy for getting around that. It's got this thing called a string pool, so that when you create a string in this way, using a literal value, it doesn't create a new object on the heap. It grabs that string and puts it in this pool of strings, not actually on the heap. And we'll come to that. We'll deal with that a bit later in this session. But just for now, it's almost, you can see you can almost treat it as one or the other. But by the way, you'd never normally do this. You'd never normally do it that way. That's the preferable way of doing it, simply because Java have created this thing called the string pool because it's more efficient. Therefore, they recommend that you use it. So if I had a string that I wanted with the value of John, I would do it that way rather than that way. You can do it this way, but you're kind of saying to Java, look, I don't want to use your string pool. I just want to do it the traditional object way. It's like overriding the ordinary Java behavior. So if we look at these two strings here, they've both got the same value. Again, harking back to beginning of chapter 2 when we were looking at all those different operators, let's see if they are equal. So I'm saying here, does name, this one, equal my name here? So I'll print out the value of it. Would anyone know what that's likely to be? They've got the same value, but okay, let's run it. I'm expecting that to be false, because when you do equality like that, this is equality. You're checking for equality. What it's doing, it's not particularly concerned about the value in here. It's saying, are these two objects the same? Are they pointing to the same place in memory? Well, they're not, because this one is an object on the heap, and this one is a string in the string pool. So I would expect that to be false. So and it is. But this one, if you remember back to early chapter 2, there's another method called equals, which is a method on the object class, which any extension of object, which is all Java objects, are free to override in their own way. And that checks if they're logically equal. So logically, these two are equal because they've got the same value. So logically, this does equal this. They're not the same objects, so that's false, but they are logically equal. So that should be true there. So that should, yeah, there we go. So the first one was false, second one was true. By the way, this I started to use that quite a lot there. Probably familiar with it. It's just a new line character. We're saying, because to make our output more readable, we're saying give me a new line character there, and that's why we got that space there. So the escaped n is a new line character. So that's checking for equality. The fact that you can initiate strings in different ways, checking for equality, using equals operator and equals method. So here again, it's a string. Again, it's a feature that is kind of unique to strings, because the plus operator, which we used a lot in chapter 2, a binary operator, is used in obviously operations like additions or whatever. But when the JVM sees you using this plus and there's a string somewhere in it, it doesn't act like an addition anymore. It acts like a concatenation. So here, statement 1, we're saying string equals, and then 1 plus 2, and these two are literal integers because we've just written them straight as numbers. So these are literal integers. They're not inside quotation marks, so they are integers. So what you'd expect to happen here, if we print out the first one, is that because it comes along and it sees, okay, you've got an expression here, an expression that we're going to be assigning to that. We're using a plus operator, and it goes left to right, seeing what all the operands are. And the first thing it thinks is, okay, you're using a string. So anything else that you add here, can concatenate it to make another string. So when we add that, when we evaluate that expression, it's going to say string equals 12, because it's not going to add them in the mathematical sense. It's going to just append each one to the string. But here, what we're doing, we're in brackets. Remember, we can override precedence in expressions with brackets. So here it's going to come along and say, okay, there's an expression here. Ah, right, he wants me to do that first because it's in brackets. Okay, what's the integer 1, add the integer 2? It's 3. So it works that out. Then it says, okay, now it wants me to add it to this string. Ah, but because this is a string, this will have to be made into a string as well and appended to that. So what you end up with on that one is string 3. So this time it's actually treated these as integers first. Now this third example here, I don't know if anyone will know what this one's going to produce here. Again, you're using the plus operator, no brackets or anything, but the first two are integers and the last one is a string. So have you got any ideas what that's going to produce when I do this? Well, what it'll do, it should be 3 string. Well, let's try it first to make sure. 3 string, and it's because it comes along and it says and it goes left to right unless you tell it otherwise. So it says, okay, integer there, add them together, 3, add them to this is a string, so concatenate them to this string. So it's 3 strings. It kind of ties into all the stuff about operator precedence and the ordering of things in an expression and overriding of things with brackets, that kind of thing. Just that plus acts as a concatenator with strings, whereas obviously it acts as an addition operator with integers or numeric types. So another way of achieving the same thing as plus is using the actual method concat. What I've done here as well in this class, I've kind of started to label things, number them, because you're going to look at a lot of different string methods as we go through this test class. So this is number 1, concat, the first string method we're going to use. So here we've got a string and we're calling it 1. Again, it's the string pool way of doing it. We're not saying new string, we're saying string 1 equals 1, so that'll put that on the string pool. And here we're saying, give me a new string. It's going to be the value of this one, concat 2. So it's almost just like saying 1 plus 2 with strings. So as you can expect, that's going to print out 12. Let me print it. Yeah, I'll just put that in again there to make it like separate from the last examples. Now, Java strings are immutable, which means that once you've set a value on them, they can't be changed. And we'll look into that in detail now. But yeah, we've got this class. It's such a sort of it's quite a initially difficult concept to grasp. So we've got our own separate class for it, string immutability tester here, and it starts off with exactly the same example I just used. So we've got string 1 equals 1, the string concat string equals 1 concat 2. So that's the exact same example we used before. I'll change this to this one now and run it. And we've got 12, like exactly as before. So then we're going to get concat string, which now has the value of 12, dot concat 3, and we'll then print concat string on it. So would anyone know what that's going to be print when I do that? You can guess what that's going to do. Got any ideas? Well, it might be surprising. So basically, at this stage, we've got the string concat string, and we know its value at this stage is 12. So you might expect that when you get concat string, which is currently 12, and concat 3 to it, it will become 1, 2, 3. But it doesn't. It just stays as 1, 2, and that might seem unintuitive. It might seem strange. Why is it doing that? Because you clearly issued this command here. Well, we can demonstrate that with another very similar example, which I think I've got here in immutability of strings. And last time we did this, we had mainly Indian people in the room, so like we used the example of Sachin Tendulkar just to keep them happy. But basically what we're saying here, so here's another code example. We're saying string s equals Sachin. So there it is. There's a string, and it creates Sachin on the string pool. So this is our string pool that we were talking about, the string pool here. Then we're saying s concat Tendulkar. So what it does, it takes this and it concats this to it to make the string Sachin Tendulkar. But what it does, strings are immutable. You can't change the value of a specific string. So the original string Sachin just stays as it is, but a new string is produced with the concatenation in it there. But the thing is, your pointer s, your variable reference, is still pointing to the original one. There, it's still pointing to the original one. So you create this new thing, but it's completely futile because nothing's pointing to it. It's just lost in there, and will eventually get garbage collected. Nothing's pointing to it. So it's done it all right. It's created the new object, a new string in the string pool, but it's lost immediately. Nothing points to it.
Could you pass that to a new string?
Exactly, that's it. So what you do here, so to get around that, second example here is exactly the same, but this time, excuse me, the second time round, you actually, the first time round it didn't have this s equals. So you're saying take s, the original variable, make it equal to itself, concat Tendulkar. So what it does, the first time it creates the first string Sachin again. Second time it creates the new string Sachin Tendulkar, and it points the variable at it. So the red line there is the difference. So it just shows you that strings can't be immutable. They can't be changed. Like if you look at many other classes, like animal class that we use in some of our demonstrations, you can change the value of them. Like if you create a lion called Leo, you can use setter and getter methods on it to change that, and you're changing the actual same object instance. And those classes are considered like changeable or mutable. But these strings are not mutable, and that's all due to the efficiency of the string pool, why they shouldn't be made mutable. But coming back to this example again, the way we'd get around this is we just do this. Instead of having this, we would just do, we would do this, equal to itself plus 3. Now this time it will print 1, 2, 3 there, and there it is. And just that same, here's that same Sachin Tendulkar example there that we had before, just the same as on the diagram. So it just prints the word Sachin, but as long as we make sure that we reassign it to itself again here, it should print the full string the next time round. So that's immutability. Just to say, the compound operator can also be used on strings. Compound operator, if you remember, is this. It's a shortcut operator there. It's the same as saying assignment string equals assignment string plus 2. It's like a shorthand way of doing it. And because that implicitly has a reassignment in it, that will also get round the problem of immutability. So when you do this, you should find that will end up being 1, 2, 3. You won't have lost those. So there we go, 1, 2, 3, because each time you're doing a reassignment again, so you haven't lost that here. And just to hammer the point home, there's a couple more things in here. So this string is called strings are immutable, and again we're creating it the old-fashioned way like that, the object way, and we're giving it the value immutable. Then we're saying strings are immutable equals and another string, I am a different object. So it's the same reference variable here, but you're not changing the value of it. You're simply, here you're pointing it to one object on the heap, and here you're creating a new object in the string pool and pointing that variable reference to it. Two very separate immutable objects get created there. And again, this is just another repeat of the same thing. We've got a string called hello, then we do hello concat world, and then we print hello. And if we hadn't just had the last 5 minutes, we might expect that to say hello world, but it's because of what we just learnt. It's hello. We would have to just reassign it to itself here. We wanted it to say hello world. So that's like the immutability pretty much done now, I think. Back to this original class again. We already looked at the compound operator there in the immutability one. Use that as a starting point again here. Go back to the string tester. So compound operator there, and all the time this will be creating lots of different strings on the string pool, and changing the variable reference to the new ones as you keep going. So compound operator on strings 1, 2, 3. So now we've got. So we looked at the string pool. So now we're going to look at some basically Java string utility methods that we commonly use, and you're probably familiar with many of these. So first, again, I continue with the numbering here. So we already had concat. Next one is length, and I think further down here, actually, we've got. Yeah, actually, before we do that, let's actually. So we had a separate class which demonstrated immutability. We've got another separate class here which really hammers home the point of what the string pool actually is. And there's a load of text in here which is sort of adapted from what's in the book. But just to demonstrate again what the string pool is and how it differs from creating objects. So here we're creating objects in, like say, the old-fashioned way, or treating them just as objects. So we're saying string 1 is a new string, hello world, string 2 is a new string, hello world, and string 3 points to string 1. So it's not recommended to create strings like that. They recommend that you use the string pool, but it's perfectly valid. And we can kind of look at that. There's a similar example we used a few sessions back. I think it should be open in here. There it is. Now we're actually using the example here of a file as opposed to a string, but the principle's the same. Those 3 lines there are very similar to the ones we used in our test class. And just to see what's happening on the heap in the stack when you do that. So here you're saying, give me a variable of type file called x. There it is there on the stack, and point it to a new file object on the heap. And that file object is going to point to an actual file somewhere on your file system called myfile.txt. Well, there's the file. That's kind of irrelevant to this because we're talking about strings. But so there it is. X is on that. You've used a new keyword, so you get a new object with a new object reference, and X is pointing to it. Y does exactly the same. So it's pointing to the same file, but it's a different object doing it with a different reference and a different variable. And then Z points to X. So Z simply points to X there. So they're pointing at the same object. And that's exactly the same as what we've got going on here. So if we, this is a string pool tester, but before we get to the string pool, we're showing like how traditional objects work. Then we'll look at string pool objects. So if we're going to test S1 and S2 for equality now. So do you think they are? This one and this one. Does S1 equal S2? Any ideas? Well, they don't, because again, what you're looking at here, what you're looking at here, you're not looking at the value. You're not looking at the value. You're looking at the object reference. So if you look here, so X and Y here, they're not equal because X is pointing to this and Y is pointing to this. Yeah, the value might be the same, but the actual objects are different. So that will actually print false. String pool tester. That's false. But S3, does that equal S1? Well, you're saying S3 is pointing, it equals S1, and what that means in object terms is that, I know the variables are named differently, it's a slightly different example here, but this is the equivalent of what that last thing is saying. It's saying make the first one a new object, and make the second one simply point at the same object that the first one is doing. And that's what we're doing, here. So S3, do you think that's going to equal S3? Yeah. So that is going to be true, I hope. Yeah, because they're pointing to the same object. That's the key thing here. And does S3 equal S2? So does this one equal that one? Well, no. That's the most definitive one at all, because you're saying you're effectively saying, does this here, is it the same as that there? And that they're not. It takes a while to get used to this sort of thing, but it's just the thing to hammer home is you're dealing with Java objects on the heap, and equality only works if the actual objects they're pointing to are the same. It doesn't matter about the value; it's the actual objects in the actual objects in memory. But here we've got strings created the string pool way, so they're not going to create objects on the heap. They're going to create strings in the string pool, and one of the ways that the string pool increases efficiency is if that object already exists in the string pool, it'll just reuse it. It'll point both of these. So here, this is the first time it's being used, so it'll create a new object in the string pool. But here, it's saying, okay, you want to create a string called hello world in the string pool, but actually there's already one there. So I'll point these two to the same thing. And what we tend to do, you'll probably notice it yourself when you're writing automated tests and things, we do tend to use the same string over and over again. Like if we're testing things for equality, the same string might come up lots and lots and lots of times. So the string pool does maximize efficiency doing that. It reuses the same string over and over again. So this time, we're using the equality operator again. Are these two things pointing to the same object? Do you think those two things are equal? Do you think they'll be equal this time? Well, yes, because this time they've created the string pool has been efficient. It's said, okay, you've created it once, I'm not going to create it again, I'm just going to point both these variables to the same thing on the string pool, so they are equal. And just what makes it a little bit more clear, I hope, is now we'll use the actual equals operator. So the equals operator is, are these things logically equal to each other? Well, every single one of these objects, S1, S2, S3, S4, S5, they all have a value of hello world. So they're all logically equal. So I'd expect all of those to be true. That's the difference between the equals method and the equals operator. So all those should be true because they've all got the same value. All true. If you were to change, let's say S1, if we were to change, just put something in there like that, then there's a couple of falses crept in there now. But they now absolutely have an identical value, so equals will be true for each of them. And just to sort of labour the point again, we're now saying, now we're back to the equals operator again. Are these pointing to the same object? Well, S4 is a string on the string pool, and S1 is a brand new object on the heap. So you definitely expect that to be false. So that's going to creep in. There's that one, false there. So so worth just, if it's uncertain, it's worth just really studying the differences between the equals operator and the equals method. And the equals operator, that's definitive. You're just saying, are these literally the same object you're pointing to here? Whereas the equals, this is open to interpretation by the developer. Like, so when we created our animal class, we are free to override that method. That means to take it from the object class and write our own version of it, to decide ourselves what is logically equal. We might decide that if a name and the type of animal are both the same in both objects, we'll return true for that. It's up to us, it's up to the developer to decide what that logically means. If you don't override it in a new object, by the way, it just behaves like that. It just behaves like that, equals. But we revisit that equals method later on anyway. So So having really laboured the point with string immutability and the string pool, it's just time now to just look at some more of the actual string methods. So go back to this string tester again here. So we already did concat, labelled that number 1 there. And some of these, hopefully quite a few of these you might already be using, or if you're not, you might think, oh yeah, you can see where there's a use for this. There's about 14 we deal with here. 14, so we'll just do them one by one. There are a lot more in string methods. You can always have a look at this class and actually have a look down it and see what they are. But those 14 are the ones that the syllabus specifically mentions. But you can always have a look at this class itself, and just sort of pick out a few methods there. So, like for example, compare to. Right, I've just picked one at random. Compare to. That's not one of the ones we're looking at now. That's not one of them because it's not on the syllabus, but it's there. That string class is well worth just investigating yourself to see. And of course, you can always see what in an ID like IntelliJ, you can always just see yourself what the methods are. You can use the dot operator and just control space, and it'll give you all these different things that you can possibly. You can see there's a lot. There are an awful lot of methods in there that could be very useful. So we're just looking at probably not even half of them here, but these are the ones that you might be tested on the syllabus. So and they all return different object types or primitives depending on what they do. So for example, we've got a string here called 10 characters, and it is 10 characters, well, kind of 10 numeric types, but wrapped in a string, in a string format. And one of the very common things we do is what's the length of a string. So we can just call the length method on that, and it returns an int, so we can assign it to an int type. We can't assign it to a string, for example, because that method returns an integer, which makes sense because you're telling me how long is this string. Well, it's a numeric type, so an int, and then we can print out what the value of that is. And I'm running the wrong class there. That's the one. String tester. Length is 10. So this is another useful one. Char. Now, string is basically a string of chars, of characters. So obviously a character is an individual letter, and you can find the char at a certain position. One thing to bear in mind here is that these are 0 indexed, which is very common in Java. Like you'll find the same thing with arrays or lists or maps or whatever. Usually the first character is character 0, and using that logic, so character 0 would be 0, character 1 would be 1, character 2 would be 2. So the char at 2 is 2. So just print that out. So it returns you a character at a certain position, and there it is. It's a bit confusing because we're saying 2 and we're getting 2 back. So just to prove the point, we can do this now. Add that in there and run it again. Now the length's changed to 11 now, and char at position 2 is now t. So you can see how that works together. So that's 3 methods. Indexof is number 4, and this demonstrates the principle of overloaded methods, which is something that I think plays a big part of, is it in here, chapter 5. But what overloaded methods are, most of you probably know, is you've got the same method, but you've got different arguments to it. So the method, for example, here you want to find, so the index gives you an integer. It tells you whereabouts in that string does this occur. So, and here is a character, a char. You can tell it's a char because it's got single quotes. But sometimes you might want to know where a substring is. So a substring, or where a string appears in that. So here, that is double quotes. That's a string. So here, this is an overloaded method of that. Here you're saying, tell me where the index of a char is. Here you're saying, where is the index of a string? And here you're saying, where's the index of a char? But I want to start from position 4. I'm not interested in anything before position 4. And the same here with the string version of it. And if you do this again, you can see like where you're offered multiple versions of the same object name. That's because these are actually overloaded methods. So if we actually look in the string class at indexOf, you can see what this does. It actually says, okay, he's asking where is the index of this char in this string, and he's not passing in from index. Therefore, we'll just start from the start. So it then calls this other version of the method and just starts from 0. So if we click that, notice we're on line 1502 here. We're now on line 1545, and it's the same method but different arguments. Won't get too far down that now because that's coming in chapter 5, but just to tell you that you can get overloaded methods that kind of it's meant to be efficient, because you could write completely different methods here with different names that achieve these things, but they're doing almost the same thing. So you're leveraging the power of one method by slightly changing the methods to it, and this one is simply calling the other one. So it doesn't an inefficient way of doing this would be to reproduce all this here in the original method, but just change the arguments. But what we're actually doing is we're just leveraging all that logic in one method and just manipulating it through what we pass as arguments. If that's not clear for now, don't worry, because we do deal with it in more detail in chapter 5. But indexOf returns an integer, because you're saying whereabouts in the string does this exist. So n there, well, it's the second thing, but we start from 0, so that's 0 and then 1. So I'm expecting that to return 1 when we run that, and it does. So that's in there. The second one, we're saying, well, where does that substring occur in here? Well, it's right there. There it is. So I think, is that going to be 4 or 5? Let's have a look. But it's deeper into the string. 4. There we go. Index of A. Now, if we didn't have that there, that would give us 0. Just prove that. So that'll give us 0. First time, because it's the first. Oh, so I didn't uncomment the printout statement there. Because we're saying where is A in that string? Well, it's 0. It's the first thing. But we're saying, well, actually, I'm not interested in anything. I'm not interested until anything up until the 4th character. So ignore the first, everything up till there. So now if we run it, it will tell us that it's actually at position 4. So 0, 1, 2, 3, 4 there. That there, yeah. That there, Giles, yeah? Yeah. Next of 4, that's right. Another thing to note is that where something isn't found.
Sorry, John, can you just do that?
Run that again? Yeah.
3.
Run those 3, yeah. Next 3. There it is. Yeah. Next 3. Don't understand that. Okay.
You're saying you start from 4.
Yeah. Well, you start from 4, which is, it might be easier if we if we started from 2, for example. Would that make it easier to understand? 4. If we started it at right, another thing to mention is that if it doesn't find anything, it just gives you the value -1. That's like the standard for, I haven't found this. So if we start this at 5, it won't even start looking till it gets there. So it won't find it, it'll give us -1. Like that there. But if we start at 4, we're starting at 4, it starts there, so it does find it. It does find it there. But I think what might be confusing you, Peter, is that we're saying start from index 4. Well, if we start from index 4, you might expect it to say, oh, well, it's in position 0 then if we're only starting in position 4. Yeah, but that's not quite what it means. It means don't bother looking at anything before 4, but once you find it, tell me its actual proper position, like right from the start. So I know it's a bit confusing, but you know that's kind of what it means there. And this final one, it's looking for AL, which does exist in it as substring, but it's giving us -1. That's because we're only starting there. So obviously, if we started there, that would work. So that would work fine. I'll put that back. Okay, so that's indexOf. Substring now. Again, we've got two overloaded methods that it wants us to look at. In other words, two versions of the same method. One of them just takes a single string, and the other one takes two. Well, the first one, what you're saying is, give me a substring. Give me the substring of animals starting at position 3. So 0, 1, 2, 3. So I'm expecting that to just print males. If I've counted that right. There it is. But what you can do, so what you're effectively doing with this substring, you're restricting where you start. But you can also restrict where you finish. So start at 3 and finish at 4. So if it starts at 0, 1, 2, 3 and finishes at 4, that's just going to give us M, I think. So run that again. Yeah, so string variation 2 with the 2 methods in there. So another thing just to point out at this stage, all these, so you can see there's lots of useful methods on string. We've only dealt with a few so far, but you can see there's many of them, and you can chain them. So what that means is that you can use the result of one as input to another one. So we've done indexOf and substring. So indexOf returns an integer, as we know, because you're saying whereabouts in this string is n, and it's position 1 there. And substring takes an int as an argument, so you can use that. That'll be evaluated first. It'll return the value of 1, and you're passing it into substring. So it's effectively the same as that. So effectively the same as that, but it does it in 2 steps. It does it by doing that first and then that. So if we just print the value of that chain, and what we'd expect, so that's going to return an index of 1, and then we're going to substring from position 1, so it's going to print everything but the A, I think. So animals, there we go, animals. So that's chaining. That's chaining of it. So the 6th method is, all right, these two are fairly self-explanatory, 2 lowercase and 2 uppercase. So we've got a couple of strings here that with mixed cases in them. I think the only difference is that the 3rd character there, or character position 2 using the 0 index, one of this one is in animal 2 it's lowercase, animal 3 it's uppercase. So we're just going to lowercase the whole lot there and uppercase the whole lot there. So fairly intuitive one there. Just run that. And there we go, so it gives us the lowercase and the uppercase one there. Equals, now we've already talked about this one. We've already talked about equals. Equals method is not declare. Well, it actually comes from the object class. So if we come again, if we go to the top of this, I'd be after all the. So the string class. If a class doesn't extend anything else, it implicitly extends the object class. So the object class contains the method equals. But what we can do, but so if we come in here, what we can do is I've gone into that method equals, but as I said earlier, developers are free to override that method in their own classes. So what this is actually defined in the object class, but we're overriding it in the string class. We're saying, well, what the object class does, that just compares object references and tells you if they're the same. In other words, it behaves like the double equals operator, but we don't want it to do that. That's isn't meaningful for us. So for a string to be meaningfully the same, they basically have to have the same values. And what that's doing there in this equals method, it's getting the two different strings. So itself, this always means itself. Compare me to the other string you're giving me. Compare and it'll go through itself and the other string that it's going through one by one. It's getting all the chars into arrays there, and it's basically comparing that they're the same, that the length's the same, and everything else, and it returns true. And as soon as it finds something that's different, so if it's saying like, okay, the char at position I of my string is different from the one at position I of the other string, therefore immediately return false. We know they're not equivalent. So that is a very typical kind of equals method that compares the value of two strings to make sure they're meaningfully equivalent. So going back to our tester again, tester class here. So if we hadn't overridden that in the string class, if we hadn't done that, and I did control click here, it would take us straight to the object class, because it would like leapfrog into its parent. So it would go straight to the object class, which does obviously have the basal implementation of equals. Anyway, we've looked at it. We're saying we've already looked at it. So I think based on what we looked at earlier, we're saying does animal 2 equal animal 3? So here are the two things here. So when I do equals, any ideas? Do you think they will be the same? Or yeah. Exactly, they are not the same. So because they're literally not the same. Just check that here. Equals is false. If we did that, of course, they would be the same. True. Now, also, if we did, just like I know we're kind of hammering this point home here, but if we did this as well, just to really hammer home the difference between equals and the equals operator, if we did animal to equals animal 3 like that. So I've changed those now, so I'm expecting that to give us true. It does there, it gives us true. But obviously if we converted it back to that again, it's false, because what we're saying here is create me an object on the string pool with that value. Then we're saying to Java, create me an object on the string pool called that value. It checks in the string pool. It says, does that already exist in the string pool? No, I can find something very close to it, but it's not absolutely the same. Therefore, I have to create a different string on the string pool. So that's why those two are the same there. I'll just note to myself there to add a few comments to that. Okay, so now we go on to something called equals ignore case. Now this one is specific to the string class. So this one isn't overridden from the object class, because if you think of a generic object, case, case. I mean, this is clearly talking about the case of letters. So that wouldn't mean anything in the object class. It's too specific. So this equals ignore case is actually written in the string class. It's not overridden from the object class. It's written in the string class itself. And this one, obviously, it's because people might not care if something's got a slightly different case. The classic example I often find in testing is where you have someone's name, for example. Like you might say, my name's John, I've written it with a small j. I read something from a file, and it has an owner name on it, and the owner name is John, but in the file it's got a capital J. So I bring the two back and I compare them. Well, I actually don't care if one of them's got a capital letter, and I know that John, lowercase and uppercase, I know it's the same person really. So I can say, well, I want my equality to extend to ignoring the case of these things. So now we can do this, and even though equals is going to give us a false, equals ignore case gives us a true. And that is, I've used that quite a bit in automated testing. It's quite handy if you're not bothered about being that strict about it. So starts with, and you'll see here that these return booleans because you're asking a question. You're saying equals. You're saying, does this equal this? You're asking the question. You want a true or false. And again here you want a true or false. And here you want a true or false. You're saying starts with. So this method is starts with. We're saying, does animal 2 start with lowercase a, uppercase n? And it does. So we'd expect that to return a true for us. A negative version of that, does it start with that? And no, it doesn't. So that you'd expect a false there. So starts with is method number 10. Yeah, true and a false. Very similar here with ends with. We're saying, does animal 2 end with al like that? And it does. Does it end with lion? Clearly not. So again, we've got a true and a false. We've got a positive and a negative there. True and false there. Contains, that's another boolean. Because we're saying, somewhere in that string, do you contain this substring? NIM. Animal 2, it does. And small I m does contain it there, but it doesn't contain all three uppercase. So again, we've got a positive in a negative case there. And true and false. So that's 12, nearly finished for today now. So trim. Now this one, it seems quite innocuous, but it's extremely useful in many situations. I found that extremely useful. What it basically does, it trims off a trailing space. So you can see here you've got a trailing space in a string there. And so if we here we have the concatenation again. So we're going to say trailing space, it equals, so we're going to concatenate these two together just to demonstrate that there's a space in there. So you'll see that there it is. So there's a space in there just to demonstrate it. So if you say we have another string called no trailing space, and we're going to make it equal to trailing space dot trim, so it'll trim off this trailing space. Now we'll do exactly the same thing. We'll just concatenate them again there. And this time it doesn't have a space there. Now I said that I found that extremely useful, and the reason is that quite often when you're doing data manipulation, you're quite often reading things in, say for example from database tables or flat files, or you're splitting an array into substrings, and very often a trailing space might be in something that you do that from, like a database might have been populated with a field with a space in it, or a file. Of course, people use spaces in their wordings. You might it's very plausible that you might get a string with a trailing space in it, and I've often seen testers or developers really tearing their hair out because they're doing a comparison. They're trying to compare that to like their expected value, which is that, and because obviously here you can see the space there because we're creating our own test data, but normally you wouldn't see it. You look in the file and you say, well, yeah, that should be 1, 2, 3, 4, 5. Why is that not working? Why is that? And I've seen hours wasted on worrying about that problem, and it's because somewhere a trailing space is sneaked in, and it's very plausible to see how that could be. If you're reading things from databases, flat files, whatever, it's very plausible to see how you could have one. And so it's we talked about how about being defensive and using guards in our code. Like for example, when we're doing checking when we want to do manipulations on an object, we check first if the object isn't null, then you can do manipulations on it, because if you do it without checking that it's null, you'll get a null pointer exception. Well, using this trim method very liberally when you're comparing strings, especially strings you're not sure of their source, is again very defensive coding, because you're basically taking out of the equation the fact that you might have a trailing space in there, and that then therefore invalidate any equality that you want to. Of course, sometimes you might want to have a trailing space in there, in which case, of course, you wouldn't use that method, but it's there for you, and it can sometimes be very, very handy. Same with these with the upper and lower case. I've seen that very often, like baffle people in testing, like that they have an expected value they want, then they read something from a database which they know should be the same, and it fails because they're using equals. But using lowercase, using equals ignore case, or making things all lowercase with this method before you compare them is another way of getting around that, you know, inexplicable, you know, just take that out of the equation. Well, is the reason this is failing just simply because I've got a trailing space, or simply because I've got one letter there that's a different case? So those methods are there to take those out of the equation if you want to take them out of the equation. And then final thing here is just a replace. So that's the method number 14. So what it'll do, it'll take so it's here, it's rather complicated because we're doing another example of chaining here. But if you just home in on that on its own, first of all, if you imagine we were doing that purely on the string itself, it's going to take a character that which you tell it and replace it with a new character. So take lowercase a and put in uppercase A instead. So what all this is going to do, it starts off with literal string animal, which has got a trailing space there, and you're chaining various methods. You're chaining methods. So the first thing you're doing is animal.trim. Okay, so it gets rid of that. It gets rid of that there. Then you toLowerCase it, so it's going to be the lowercase word animal with no trailing space. Then you look for any instances of lowercase a and you replace it with uppercase A. So you've got using 3 methods all chained, and so I think the result we're expecting would be the word animal in lowercase with no trailing space, but with the A's capitalized. And I put that full stop there just so we can see if it's got rid of the trailing space. Because obviously, if it hadn't got rid of the trailing space, there it is there, we'd have another space there as well. So there's the result. So that is, in one session we've cleared a good deal of chapter 3, like a real good chunk of chapter 3, at least the first third of it. There's another, when we start the next session, we'll look at, because obviously manipulating strings and calling all these methods, we're creating new strings all the time, and even though we've got the string pool, it can be inefficient to do that. If you know that you're going to be building a string and appending to it and concatenating it and splitting it and doing manipulations on it, if you know you're going to be doing a lot of that, there are other classes that can help you do that without creating so many objects. And 2 classic examples are string buffer and string builder. And I think that up to about Java 1.5, string buffer was the popular one, and that's recently been overtaken with string builder. So you can see, just waiting for us next session, we've got this class called string builder.tester, which does a lot of these same manipulations, but it uses this class called a string builder, which is effectively a wrapper around a string. So it'll do all this concatenation and stuff and splitting and all the rest of it, but it'll do it without creating so many objects. It does it contained within this builder class, which is like a wrapper around a string. And then after that, for chapter 3, there's basically, I think we've got date and time tester, and all the manipulations that you can do with dates, times, and date and time stamps, and that's pretty much chapter 3. So we've got a good chunk of it done today, and